So one is 5, one is 7, which is not very significant, right? So we've just done two things with this. One, we have been able to get some insight in the data and the behavior of the people. We are able to say that uh, that what kind of people does this person make a friend or not, right? There's one category of feature which is expression, which we didn't do in this exercise, which we can do as homework, right? And we can see that whether that is the distinguishing feature or not. But the first thing we have done here is that we have got insight, right? The second thing which we are now going to do with this is do feature selection. And we didn't talk a lot about feature selection today, but feature selection is an important step in machine learning where we are saying that what are the discriminating features, right? And we will use the discriminating features only to make a model, right? And for the kids, now we will make the model, and it's a very simple model. What is the model? Let's first assume you have one discriminating feature. So you give +5 if the person has that feature, right? And if the person doesn't have that feature, you give -5, right? So if outdoor, indoor is a feature, then for outdoor people, you give a +5. For an indoor person, you give -5, right? And you do this for all the entries on your Excel with a simple if statement. The if statement says if this cell is equal to outdoor, right, then 5, otherwise -5. Have we given that command somewhere to them? So in the first sheet, in column number I2, oh no, this is strange. Oh no, H2. Oh, this is not exactly what we want, right? It is this, but why are you putting an OR gate? So you can modify this formula, but all we are saying is, and you can even do it manually if you don't want to put in the formula. You're saying that if the person has an outdoor activity, if outdoor is a discriminating feature for you, if he has an outdoor activity, you give a +5, otherwise you give a -5, right? If you have two discriminating features, you just add it, right? You again give a +5 and a -5, and you just add it for the two features, right? And finally what you do is you just see which side of 0 it is, and say whether you'll friend that person or not friend that person. Got it? So it's a very simple model, which says that +5 if the feature, discriminating feature is there or not, -5 it is not there, if it is not there, and then you sum it. So just do this and try to find out what is the train error of this model for you, right? The train error is that once you predict who's going to be a friend or not, you also have the original labels. So you see what is the misclassification error, how many did you get right? Right, so let me try to, okay, so let me assume, so now just look at here. So what I'm assuming here is that this person is, the discriminating feature is indoor or is sports, right? So what I say here is, if this column is sports, then 1 or 0. So can you see this formula? It's very simple. If that column is sports, then you get a 1, otherwise you get a 0, right? And now let me try to find out the misclass error. Where's the num block? Guys, can you help them quickly find the train error and the test error so that we can get done with this, just running out of time. Yeah, it's with me. You can take this. Oh, this one? You should do it. You have a discriminating features should have good train errors, may or may not have good test errors, right? Because the sample size is very small. You know, we're making a very simple model, etc., etc., etc. So these are the kind of models we have got. We got much better results with kids on the models, right? I think which is explainable because adults have much more complex choice making than kids have, right? It is way more subjective, and probably I don't know what n number of things went into your mind when you were rating these sheets, right? But for kids, the world is more black and white for them, right? So when we do this with kids, we get much better accuracy of models, right? And this is the exercise which we have done, what we took 1 hour to do it, more than 1 hour? 1 hour, right? We do this with kids in 4 hours. And what I'll really lean on you and ask you guys to do is to go to the website datasciencekids.org. So go to datasciencekids.org and you'll see there's one blog post which describes this whole thing, right? How we do it with kids. Please don't keep your laptops in bags right now. You have to do one more last thing, right? Huh? Huh? Oh, you have a train? If you have to run for a flight or a train, don't lie, but you can go. So if you have a flight or a train, please go ahead, move ahead. Otherwise, we just need 5, 10 more minutes of yours, and you can leave. So, so I will just ask you guys to go to datasciencekids.org and read this one blog post which describes the first camp which we did in Delhi. And you'll understand how to run this with kids. You can find all the sheets, all the resources which you have seen already there on that website, and you can use it. We would love if you guys go and organize this data science camps. We, just, on the feed, I can announce that for the first 2 data camps which are organized, we'll give a prize of 5,000 rupees, right? So send us pictures. It should have more than 10 students. Send us the Excel sheets which gets filled up, and we'll give you rupees 5,000, right? But go do this. But you have not been, in this 1 hour, you have not been trained enough to run this with kids, right? There's a lot of things which you need to know how to communicate with. So first thing you might have seen is that many of you struggled with Excel because you have no training in Excel, right? That's fine. I was just, while it was happening, I was thinking that we can't think that we'll teach you 2 platforms in a single day, one Python and one Excel. That's like just too much, right? So that's why we take more time with kids. But as mentors, you should be able to work with Excel fast, right? And what you'll see is that you'll have much better models with kids. So, and the interesting thing in this whole exercise is that if you see, this has pretty much all the steps of machine learning, right? Data collection, visualization, insight, feature selection, which in fact we didn't cover today, feature selection, and then model building. And also being able to split the data in test and train, right? So it covers all the steps of machine learning. It is very simple. It is something which a 6th grade student can understand, right, and understand the whole loop of machine learning, and that's how it was designed. We also have a paper written on this, that how this was all designed. So there's a lot which went behind why the way it was designed, right? And if you're interested, just write to us and we'll send you the paper which we wrote on this. But really, what I will ask you guys is to go back, read the blog, and try to organize one of these camps, and ask us for a cash prize. Also, if we had more time, we wanted you to import this data in Python, and then try to do a logistic regression, do a decision tree, etc., and see what you could have got from that, right? So you can use this data, push it into Python, what you learned today morning, and apply that to it, right? That pretty much brings us to the end of the day. The one last thing which we want you guys to do is to fill a feedback form, right? And where's the feedback form?
So you can open the resources folder, and there's a resources document. In that, if you scroll down, there's the link to the form.
So you need the internet. You need the internet to fill the feedback form. If you don't get the internet, just take a sheet of paper, copy the questions from the person at your side, and fill the feedback form. Please put your name on the feedback form, or if you want to keep it anonymous, don't say your name.